Hello everyone and welcome to the second episode of KEMA Labs podcast, where we provide news and insights on the testing and electrical sector. Today I'm super excited to welcome you in the beautiful background of the semi-anechoic chamber of Milan Laboratories, where we perform our electromagnetic compatibility testing. So today I'm here with Alessandro Bertani, the director of the Global Business Unit Services and Smart Technologies of KEMA Labs, and together with his vision and expertise that is since 30 years in the transmission and distribution industry, we will navigate opportunities and challenges for the digitalization trends for substations. So let me start with the first question. So Alessandro, how is digitalization transforming electrical sector and substations? Which are the opportunities and challenges related to?
Hi Antonio. First of all, thank you for the question. And let me say that when I started working as a technician a long time ago, I was assigned immediately to a project for revamping protection and automation system in electric substation. When I met the team of the grid system operator, I was immediately alerted by them according to the fact that there were very limited possibilities to manage systems by remote because of safety reasons.
Yeah.
30 years later, let me say that these statements seems to belong to a Jurassic era. Not only now we want full remote control of the electric substation, but also we aim to increase information and data, make data easier to transmit, share data among devices in the same substation as well as across the substation in real time, so that this information can be better exploited, processed, and acted upon. The first question is how to define a digital substation. Well, the answer is quite simple. A digital substation focuses on converting binary data, analog measurements, into digital data in a seamless and reliable way. You asked me which are the benefits of doing that. Again, there are multiple benefits. First of all, one of the aims is to reduce the capex, the investments, by avoiding duplicated hardware. Traditional current and voltage transformer, for example, are installed for each of the protection device. Dedicated CVs and CTs are not longer required in digital substation anymore, since data can be measured once and then circulated among all the equipment of the substations. And this is a paradigm behind the so-called standalone merging units. By the way, we already had the opportunity to test this kind of equipment in our laboratories. Moreover, digitalization can reduce engineering work through simplified system drawings and reduce the substation footprint by up to 50%. Thousands of copper wires and wire ducts can be substituted by fiber optic cables. The same concept for all the multiple pins connectors substituted by single plugs. Then it's important to notice that simplification in drawings and footprint has as an outcome also easier and faster commissioning of the substations, with less involvement of workforce, with operation that can be managed by remote, by very skilled and specialized teams. Also checks and in-field tests that are usually quite difficult to be done are possible with higher safety of the personnel. That is not called anymore to be close to the primary equipment during the most dangerous operations. Finally, self-assessment, capabilities of the equipment together with analysis and transmission of relevant data to control remote center for sure improve system reliability through increased situational awareness and asset utilization.
Thank you, Alessandro, for your insights. So it seems there are a lot of advantages in the digitalization process of substations, but I was wondering, Alessandro, what are the critical considerations and the point of attention for substations in this environment? Could you please elaborate something?
Yes, of course. We just talked about substitution of one-to-one current and voltage transformers, copper wires, pin connectors with communication networks, able to circulate real-time information inside and outside the digital substations. This is a great advantage, but it is necessary to understand that a common language must be used to enable such exchange of information among devices especially produced by different vendors. In this regards, 61850, the IEC standard, is a keyword very well known by all the experts in digital substations. The standard set the rules for design and manage digital substation, their functionalities, and related data flows. We started working on this item long time ago again, in project launched by the Italian transmission system operators in early mid-2000s. It's important to notice that very often talking about 61850, we refer to functional and communication compliance of intelligent electronic devices installed in the substations. A service that we as KEMA Lab provide to our customers. The equipment must demonstrate to use the prescribed rules for acquiring, modeling, and communicating data. But not only. So in the part 3 of the standard, also it is defined that there are important requirements regarding construction, design, and environmental condition for utility, communication, and automation IDs installed in power plants and substation environments. These tests on the hardware are also performed in our laboratories, giving us the opportunity to deliver a full service to our client. Not to forget, compliance to the standard gives assurance that implementation follow the rules. But when we talk about data and communication devices, interoperability is the real added value. Interoperability means that the devices are tested together to check and verify that the degree of freedom that is usually left by the standards is not jeopardizing the overall system behavior. So it's very important to test together also the equipment. Another point of attention is necessarily data protection. If from one side digitalization allows to collect and transmit a wonderful amount of data, on the other side data must be protected in their confidentiality, data integrity, availability, in 2 words, cybersecurity. Great step forward have been done in these regards. The standard IEC 62443 is the international standard defined for industrial cybersecurity, which include risk assessment, vulnerability assessment, penetration test, threat modeling, defense strategy, management system implementation, security level definition and validation, auditing and follow-up. And more specifically, there is also another standard that is the IEC 62351 that incorporates requirements of the industrial cybersecurity 62443 to be applied to manage security of the communication protocol specifically designed for the electrical sector. Again, we talk about IEC 61850 as well as 60870-5 and 6, 61960 and 61968.
Thank you very much, Alessandro, for the deep insights delivered. Well, there is a lot happening in this field, as I can see, but what are the key technologies, what are the key innovations that, in your opinion, will play an important role in the next future?
Very challenging question, Antonio. So, the path toward digitalization of a substation is clearly defined. Working groups at international level will continue working for expanding the current frameworks, the current standards. There are many items currently under discussion for covering new technologies and new functionalities. But I don't think that today is the right moment to deep dive in all these details. Let's try to see instead from a higher perspective potential future evolutions. Talking about digital immediately, another word is coming to our mind: virtual. Availability of huge amount of data, capability to collect them, analyzing them online in real time, transmitting them remotely. This means having the opportunity to create virtual representations of substations in terms of their primary equipment, their sensor, the protection and automation devices. In other words, we can create virtual copies of the substations to have previews of their behavior in critical transients, evaluating aging of the components, analyzing the effects potentially of dangerous events. Whatever we deem useful to study and analyze before it really happens in the field can be replicated in a virtual world and used to prevent major out of orders. This is a general trend in industrial plants, and I think that also the electric sector will exploit these capabilities. Sometimes this virtual environment is called the digital twin of the reality. We as CESI and also as KEMA Labs are keen to give our contribution to this development, making available our knowledge for modeling the reality and, very important also in my opinion, to fine-tune the models through our testing capabilities. But again, we must pay attention to the threats behind these concepts, because such precise and vital information for the plants must be carefully protected, even more than what I talked before. Otherwise, they give very dangerous insights for large-scale malicious attacks. As in a system like the electrical system, when there is no time to recover, where everything must be real-time, everything must be balanced and bottlenecks are not allowed, this is not sustainable.
Thank you very much, Alessandro, for your insights and for sharing your experience with us. Thank you very much.
It has been my pleasure to be here today. Thank Antonio for giving me the opportunity to talk about our work, but not only, our passion.
Great. And to our audience, thank you very much for listening to our podcast, and I look forward to seeing you in the next episode where we will share other insights and news with respect to the trends of the energy sector. And please stay tuned and remember to visit our website to engage us not only with our podcast but with other initiatives that we will publish on it. Thank you.